This is problem 25 from the magnetic field. Below are 6 configurations of 3 long parallel wires that carry current perpendicular to the page. The wires are located at 0, 0. That means this is the origin. 2A, 0, 0, and 2A. Rank these configurations on the magnitude of the magnetic field at location 2A, 2A, which is here. So make sure you're looking at the correct point in these problems. You're going to do 26 for homework. So for 26, it says at the center of the wire distribution. Okay, that's easy. That would just be right there. Okay, so we have our magnetic field for a long straight current carrying wires, mu naught I over 2 pi r in the t hat direction. And we have 3 different wires. And for this wire here, at this location, so on this line, it might help if we say if there's a circle like this centered on this wire, tangent to the circle is like this, so the field would either be going straight up or straight down, and my fingers say over here, the field is going up. And for this wire here, a circle which is centered on this wire would be like this, tangent to the circle would be like this, so the field is either going to the left or to the right, and my fingers say it's going to the left. And tangent to the circle here would be like this. My fingers say it's going up and to the left, and that arrow is going to be smaller because this distance is greater. So we have r for the distance in the denominator there, so larger distance, smaller magnetic field. So for the net magnetic field, we get something like that. I wasn't really careful about the size of the arrow, so I might need to look more closely at that later on. For part B, these 2 wires are the same, so like this. And then for this wire here now, because it's carrying current into the page, the field is going this way. So overall, we get something like this, still going this way, but not as large because now this wire gives you something that's going in the opposite direction, which makes this smaller. And for C, now if this is carrying current into the page, the field is going straight down here. Remember, it has to be tangent to the circle, but now it's going straight down instead of straight up. And here, tangent to the circle is still to the left. And here I have the same thing that I had here. It's going this way. So if I add all those together, I get something like this. Okay, and then for D, it looks like that is going to be the opposite of B. I could guess that it's going to be this way. And B and D would have the same magnitude. And then I can show this, fingers going down, this, fingers going this way, and D, fingers going that way. So it is the opposite of B. For E, now this is 2I, so if the current is twice as large, the arrows are going to be twice as large. So this is exactly like A other than that. So this arrow is a little longer, well, twice as long. This arrow is twice as long, and then you still have this one here. So that gives us something like this. And then for F, that would be, is it similar to something that we had before? No, not really. Okay, so for F, we have the same length from this wire as we did for part E. For this wire here, now the field is going to the right instead of to the left. And for this here, you get something like this. So that is the net field. So I didn't do a great job with the lengths for my arrows, but I think I can still do the ranking. So E would definitely be the largest because if you add what we have for this wire here to what we have for this wire here together, you have something here, and then this wire is adding to that. For F, if you add this and this together, you get something here. And then this wire here, the vertical component is adding to that, but the horizontal component is going in the opposite direction, so that's going to make F smaller than E. So for part A, I don't really know how I want to do that here. I guess I'll just say F is smaller than E. E is definitely going to be the largest then, so let's just put that up here. And F would come after that. Okay, and then it looks like the smallest ones would be B and D, because for B and D, if you add these two together, that puts you somewhere over here, and then you're going in the opposite direction for this wire. Same thing for D. So those look like those are going to be the smallest because this wire is completely opposite of what we had to be from the other two. And then that just leaves us with A and C. Well, A should be larger than C because these magnitudes were all, for the current, they were all I. And for A, it was similar to what we had for E, where this wire is adding to what we had before. But for C, that's just kind of like what we had for F. If you add these two together, you're like this. And then for this last wire here, the horizontal component is adding, but the vertical component is going in the opposite direction. Okay, so even without doing exactly the lengths I was supposed to for my arrows, I was still able to do the ranking successfully. And then for part B, I need to rank these configurations on the basis of the angle the magnetic field makes with the x-axis. So I've drawn everything up here, and then I just need to see D looks like it's going to be the largest angle. And after D, C is in the third quadrant, and A and E are in the second quadrant, and they're both going in the same direction. Oh, so is B. So A is equal to B is equal to E, and then F would be the smallest angle. And that concludes 25.